What's up, guys and gals? This is next section. What is it? 2-3. Part of 2-3. I mean, we did 2-3 already, but this is now the quotient rule and the trig derivatives. Your homework's again on the right. We are going to use the quotient rule here. We also have to memorize and know trig derivatives. We talked about sine, cosine, but now we're going to know about tangent, cotangent, cosecant, secant, things like that. So the quotient rule, which we already know from last year, we know how to find it, but really we got to make sure we understand what it means. So it says when two differentiable functions are divided, the resulting function is also differentiable. So if I'm dividing two functions, okay, as one, so f divided by g, those are differentiable, which makes the whole function differentiable. Okay, since they're individually differentiable, it makes the full function differentiable when they're divided by. So we have d over dx, which is again the derivative of f of x over g of x, or the two functions top over bottom. We do the bottom times the derivative of the top minus the top times the derivative of the bottom over the derivative, or I'm sorry, over the original function on the bottom squared, provided g cannot be 0. Okay, it cannot equal 0. Now, we did it last year as u's and v's, right? Remember, it was u prime v minus u v prime over v squared, and that's fine too. You can do it that way too, as if you remember from last year, that's fine. Now, this is a little saying that we didn't do last year because we don't do it this way here, but it doesn't really matter. It says low d high minus high d low. Okay, low d high, so the low, which is v, d means the derivative of the high, so u prime minus high u, d low, the derivative of the bottom, all right, v prime, over the square of what's below, v squared. Okay, it's, you know, a pretty good rhyme, and a lot of old, I think, calculus teachers and math teachers will do that for you, but it's not that difficult to memorize the formula, so just memorize the formula. Not that bad. Okay, let's go to some examples. Remember, I always like to write them down, right? I'm going to use u and v just because that's what we did last year, so I'm going to keep with that same theme here. So u is 5x minus 2, and then v is x squared plus 1. We got u prime is 5. Man, I got the hiccups. V prime is 2x, right? And so then we do u prime times the bottom, x squared plus 1, minus the top, which is 5x minus 2, times the bottom derivative, right? So 2x times 5x minus 2 over, and then the bottom squared, so 2x. I'm sorry, not 2x. It's x squared plus 1 squared again. I guess if we probably, let's make sure, I guess, we have our notation correct. So y prime, let's condense it a little bit just in case. 5x squared plus 5 minus, this is 10x squared plus 4x over the bottom, which is x squared plus 1 squared. This is then equal to, we got negative 5x squared plus 4x plus 5 over x squared plus 1 squared. Now, I could have left it this way if it was free response. You probably would have to make sure you write it this way if it's a multiple choice, because I doubt that they would leave it written like this. Okay, let's do this one here. This is really the same as 3 minus 1 over x plus 5. Okay, so the top is 3 minus 1 over x. Well, I'm going to change 1 over x to 3 minus x to the negative 1 over x plus 5. So let's do it that way. You didn't really have to. If you wanted to convert it, this is the same as 3x minus 1 over x plus 5. But then that's really the same as 3x minus 1 over x squared plus 5x. Remember, these two go together. So I guess we can do it that way too. It doesn't really matter. But I'm not going to. I'm just going to do it right from here. I'm going to do it right from there. So instead of wasting all other time, you don't really have to. But I'm just telling you that's what you could have done in the first place if you wanted to. Okay, if you don't like, you know, x to the negative 1 or whatever, you can definitely get rid of it. Okay, so we'll make u equals 3 minus x to the negative 1. U prime is what? This is going to be positive x to the negative 2. V is going to be x plus 5, and then V prime is just going to be 1. That's pretty easy. And so then we get U prime, which is x to the negative 2, times the x plus 5, which is V, minus. We get V prime, which is 1 times U, which is 3 minus x to the negative 1, over x plus 5 squared. Alright, I don't really want to mess around too much with it, but maybe we should, I don't know. Yeah, I guess let's do it. So if I multiply and distribute this out, this is still equal to f prime of x, right, notation. So f prime of x is equal, let's distribute that, that's x to the negative 1, because remember I add powers, plus 5x squared, I'm sorry, 5x to the negative 2, dirt, minus 3 plus x to the negative 1 over x plus 5 squared. I guess let's, I don't really know if you want to keep going. I guess I will, just to show you that you might have to go further on the assessment, on like the quizzes and tests and everything. So I guess let's do that. So I'm going to bring this way up here. So it's 1 over x, I'm going to get rid of the negative powers, plus 5 over x squared, minus 3, plus 1 over x. All of that's over x plus 5 squared. So I need a common denominator, it's x squared, so common denominator is x squared. So that means this is going to be x over x squared, x over x squared. That stays, this is going to be 3x squared over x squared. And this is going to be x over x squared. And then combine everything on top, so I get x plus 5 minus 3x squared plus x, which goes to negative 3x squared plus 2x minus 5 over x plus 5 squared times x squared, because remember this goes down below, I think. Yeah, I guess that would be that's a good answer right here. You probably could have left your answer something like that, maybe on a test. Again, free response. I mean, a free response, I would have left my answer like this. Okay, but again, you got to make sure you kind of know how to mess with negative powers and common denominators and stuff like that. So I think that was a good example. Here, tangent of x. Now we haven't gotten to really what the derivative of tangent of x is yet. But we can use quotient rule on this because it's really the same as saying it's sine of x over cosine of x. And so now we can use quotient rule and saying, okay, u is sine, u prime, right, is hopefully cosine, you remember. We get v is cosine, and then v prime, remember, is negative sine. And so then, even if you forget the derivative of tangent, right, remember it's like secant tan or something like that, I don't even remember. Because I don't have to, but you can still definitely break it up into quotient rule and go from there. So let's get u prime, which is cosine of x, times, oh, maybe it's secant squared, I think it's secant squared, times cosine minus a negative, which is really plus, so that's sine x times sine of x over the cosine squared of x. Okay, because I got to square the bottom, right? So I get cosine squared plus sine squared. Now remember that's 1. Okay, remember cosine plus sine squared is always 1. That's from trigonometry. That's over cosine squared of x, which is equal to secant squared of x. So we can say that the derivative is equal to secant squared of x. So there we go. Right there. All up in the club. Just kidding, I don't go to clubs. Trigonometric function review. So here we go. Please remember that 1 over sine is cosecant, secant, cotangent. You need to know those. Cotangent is also written as cosine over sine. So instead of tangent being sine over cosine, it's the opposite, right? Or you can rewrite it that way. And remember, we just use this. This is called the Pythagorean identity, if you want to be more specific, but that's what that is right there. And then here are your derivatives here. Sine is cosine, cosine is negative sine, tangent is secant. So that's what we just did. Cosecant. If you forget cosecant, remember it's 1 over sine, right? And then you can make u is equal to 1, u prime is equal to 0, v prime, v, and stuff like that. You can definitely find the answer out by the quotient rule if you forget the actual fundamental identities of these trigonometric functions here. So what I want to do is use that information and then do these 3 examples on the bottom. So 2x minus tan x. So this is pretty easy because this isn't even a quotient rule. It's just a regular power rule and then the derivative of tan. So this is just 2 minus secant squared of x, right? This is where if you remember tangent, then you go there. If you don't remember tangent, then you got to do quotient rule, and then that's 5 more minutes down the drain. Okay, so just try to do that, I guess. This one here, we're definitely going to have to use quotient. I can do this 2 ways. One is I could say, okay, it's 1 over secant x minus cosecant over secant, of x. And I could definitely say, okay, well, this is, so secant is really what? 1 over cosine, so this is really just cosine. Cosecant is 1 over sine. Secant is 1 over cosine, which is cosine is going to be on top. So then what happens? This is really just what? Minus, and then that's cotangent of x. So I could definitely do that. These are your trig identities. And then you can say, okay, well, this is really the same as that. So then I can take the derivative and say, okay, cosine is really just negative sine, right? And then cotangent is, if we remember, because I don't, is negative cosecant squared. And so then it would be negative cosecant, but that's already a negative, so it's really plus cosecant squared of x. And let's just make sure that's the right answer. That's not what I got on my notes, but that's okay. Let's do it the quotient rule now, so we don't have to do this fundamental garbage here. So I'm going to write down the answer that I got. Hopefully it matches. If it doesn't, then I guess I'm going to be mad and probably get fired here, I guess. I don't know. Let's see. Let's see if I can do some awesome stuff. Yeah. Okay, so if I do quotient rule, right, so then u is 1 minus cosecant x. U prime, that's just 0. Cosecant, what does cosecant go to? Cosecant goes to negative cosecant cotangent. Okay, so negative and negative makes positive, so this would be cosecant, cosecant cotangent, and then v is secant, and then v prime is secant tan. I remember that one, right? Okay, so now I do u prime, which is cosecant. I always mess that up. There we go. Cosecant cotangent x times secant x minus now v prime, which is secant tan times 1 minus cosecant over secant squared of x. Now what? What can we do now? Oh, this is actually pretty cool. So this is an awesome kind of thing here. So in my notes, so because this term has a secant of x and this term has a secant of x, I can cross those out, and I'm left with f prime of x is equal to cosecant x cotangent x minus, I want to distribute that through, tangent x plus tangent x cosecant x, and all of that's over secant x. Wow, that's kind of crazy there. I don't want to spend any more time on that. I'm going to assume that these are equivalent. I don't really want to do any more like manipulating, but I guess I could. 1 over sine, that's not good. That would be, I'm done. Okay, I'm done. If you want to do it, you can. I'm going to guess those probably are equivalent, because I'm going to guess a lot of stuff will cancel out. And so, yeah, I'm going to call it a day there. Number 3, this is definitely product rule, right? So product rule is u prime v plus uv prime. And so we'll say this is definitely sine is u. So u prime is cosine x tangent x plus u is sine x. And then derivative of tangent is secant squared of x. I think I could probably leave it that way. I can. If you want to cancel stuff out, you can try and get common denominators and stuff, and you can, because really cosine tangent is really just sine of x, because the cosines will cancel. This one here is going to be really plus cosine squared x over sine x, so that would be cotangent x is also times cosecant x. If you want to, wait, no, that's not right. It is cotangent x, hold on. So it's cotangent x and then cosine x. If you wanted to find, oh, and then, or because I get common denominators, this becomes sine of x and this is sine squared. So this is really sine squared plus cosine squared is 1 over sine of x, which actually becomes, right, cosecant of x. So the derivative actually could become cosecant of x. Wow! I blew your mind, and I wasted probably 10 more minutes of this video than I probably should have. But again, just because it's a trigonometric function doesn't mean we can't have multiple answers and they could all be right. Okay, it depends on how you do them and how far you want to break them down. Okay? Wow, that was really exciting, huh? Right? On to the next lesson, I guess. Deuces.